Okay. All right, so here's the activity. Harry, can you read me your C values here? Just read it straight across for me.
0, 5, 10, 15.
Okay. All right, those look good. And so when we plot these ordered pairs, I'm just going to go ahead and do that. 0, 0 is here. 1, 5 is here, and so on. Okay, and so clearly those look linear, right? It's a linear relationship, right? The other thing I want you to notice is not only is it linear, but it passes through 0, 0. That's another important thing I want you to catch here. By the way, you can't have negative number of movies, so I'm not going to go beyond this point down here at the bottom. Okay, but in the other direction, it would keep going, wouldn't it? Right? You can download more and more movies, and the cost will go up and up and up, right? So that'll keep going like that. Okay, but anyway. And so what happens here, Katie? It starts at 0, 0, and then when one of the variables increases, right? Like when n increases, what happens to the other variable? What? It increases as well. Okay? So again, a situation where it starts at 0, 0, and then the y values increase directly with the increase in the x values. That's called a direct variation situation. Okay, now we want to write an equation. Okay, and so Mark, what did you come up with? The cost C equals what in this case?
C equals n minus 5.
So, for example, to get to 10, you would take 2 minus 5. 2 minus 5 would not give you 10, would it? What is it? How do you get from the n value to the c value each time? You what? Multiply by 5. So what is it? The cost equals what? 5, yep, 5 times n. Okay, good. Makes sense, guys? And that makes sense because this is kind of like what we did first semester, right? With slope-intercept form, right? The slope here is 5, isn't it? And the y-intercept is what? What's the y-intercept? 0, right? Got it? All right. All right, Easton, can you read me the links here? Starting here. Just
24,
12,
8, 6, 4, 3, 2.
Okay. All right, everybody agree with those? Okay. Clearly the width times the length has to equal 24, doesn't it? Yes? Okay. And so we just fill those in, and now we're going to plot these points, like 1, 24, for example, that would be here. 2, 12, that would be here. 3, 8, and so on. Careful, you don't want to plot any of these incorrectly. And then we got 8, 3. We got 12, 2. We got 24, 1. Okay, so if you connect those, it's going to look like this. Okay? And you guys, you could continue this, right? And what would happen here is if you continued this, this would continue to get closer and closer and closer to the w-axis or x-axis, but never cross, right? Same thing here. This would continue to get closer and closer to the y-axis or l-axis and never cross. Got it? And that creates asymptotes on the x and y-axis, kind of like we saw way back in this semester with exponential graphs, okay? Okay, and so in this situation, okay, take a look at the shape of that curve, and then also notice that as one variable increases, what's happening, Nick? Yeah. When one variable increases, the other variable decreases, right? Think about that. If you got L times W equals 24, right? When you multiply them, you get 24. When one goes up, the other one has to go what? Down, and vice versa, right? Does that make sense? Okay, so this is an example of what? Inverse variation, right? Okay, so, all right, so what's the equation? Well, first of all, write the equation based on the way the problem is written. What do you know? What do you know, Conrad? When you multiply the length times the width, it has to equal what? 24. Okay, so everybody agree that's the equation for the situation? But I wanted you to solve it for L. So how do I solve that for L here, Paige? What do I do to solve that for L? Yeah. You mean, wait, I want to solve it for L. So you divide by W. Okay, good. So if you divide both sides by W, you get L equals 24 divided by W, like that, right? Okay. Everybody agree with that? Okay, so when you have a variable equals a constant number divided by another variable, that's going to be what type of relationship? What type? Inverse variation, right? And in this case, you had one variable equaling a constant number times another variable. That's what type of relationship? Direct variation. Okay, so those are the two concepts we're learning today. Okay, and so real quick here, Gina, can you read A and tell me whether it's inverse variation or direct variation? Go ahead and read it.
For each situation described, see whether the variable varies inversely or directly. The number of songs you download onto your iPad and the total cost.
Okay.
Inversely.
Okay. So the more songs you download, what's going to happen to the cost? Yeah, it's going to go up. So it's direct. They're going to vary directly, aren't they? Yes? When one goes up, the other one goes up. When one goes down, the other one's going to go down. You agree that's direct variation? Okay? All right, Joey, read B and then tell me what you think.
The number of painters and the total time it takes to paint a house.
Okay, so what do you think?
Inversely.
Inversely, that's right. If you use more painters, the time it takes to paint the house is going to go down, isn't it? If you use more painters, let me say that again. If you use less painters, it's going to take longer to paint it, right? See how that's inverse? Yes? Okay, and Shane, how about C?
The number of songs you download on your iPod and the total space you need inversely.
Okay, inversely. Okay, good. Everybody agree? The more songs you download, the amount of remaining space you have goes down, and vice versa, doesn't it? Okay? All right, so those are the two things we're learning today, and we got a variety of examples to do in the notes. This was bad. There's only one there, right? Okay. All righty. Okay. John, can you go ahead and read the top couple sentences here? Okay, so in that first example, when we dealt with the movies and the total cost, we only considered positive x and y values, right? But in general, when you have y equals a constant k times another variable, certainly you can use negative x values as well, in which case the line would just continue like that, wouldn't it? With me, Lexi? Right? And so, by the way, if k is positive, again, that's a linear situation with a positive slope, so that's why it would rise from left to right. K, the constant could be negative, though, in which case you'd get a line like that, passing through 0, 0, with a negative slope, going down from left to right. Does that make sense? But those are both situations of direct variation. And clearly the graph is a line passing through 0, 0. Everybody agree with that? So those are the highlights there that I want you to remember. Okay, so with direct variation, you got a variable equals a constant number k times another variable, where k could be positive or negative, and that would result in one of these two situations. But in both cases, the lines will pass through 0, 0. Does that make sense? Okay? Now, with inverse variation, where you got a variable equals a constant k divided by another variable, as we saw in the activity, we saw the graph look like this. Okay? But we only worked with positive x values. If you had negative x values, the rest of the graph would be down here like that. So again, if k is positive, you got a constant k that's positive, the graph will look like that in the first and the third quadrant. And by the way, that's called a hyperbola. Are you with me, guys? You guys got to watch me, okay? I'm pointing out all the highlights. If k was negative, well, you'd still get a hyperbola, but this time it would be in the second quadrant and in the fourth quadrant. Is that clear? Okay, so just take note of how, whether k is positive or negative, how that would change the hyperbola. And here, whether k is positive or negative, you kind of already know how that would change the line. Do you understand, guys? Yes, go ahead.
How does, on the, first graph on the left, right there, on the inverse variation one, the one below, the x-axis, yeah, that one, how is that, greater than 0?
I'm saying if you picked a positive k, okay, and then you plotted a bunch of points with positive and negative x values. In the activity, you saw the one piece look like this when you only plugged in positive x values. If I had continued that table and used negative x values, the points would have been down here. So that's just the other piece of this type of situation that you didn't see in the activity, because we only used positive x values. But if you use that same equation and use negative x values, you would have seen the points would have been down here. Okay? And that just gives you the other half of the hyperbola. That's all. All right. Okay. All right. Now, this is important, guys, because there's going to be other ways to recognize whether it's direct variation or inverse variation. So please watch this closely. Okay? All right. If you have y equals a constant k times another variable, clearly that's direct variation. But you got to be able to recognize it in other forms. So if I divided both sides by x here, you would get this. Okay, are you following me on that? If I divided both sides of my equation by x, I could turn it into this. So, in this case, if you divide your two variables and you always get the same constant k, that's going to be direct variation. Is that clear? Okay, you're going to have to recognize that. Okay, again, in the activity, when you had length times width on that taffy equaled the same number, you got that. And then we solve for y, you got that. So again, these are the same situation. You can write it either way. So again, if you start with this and divide both sides by x, you're going to get this. If you start with this and multiply both sides by x, you're going to get that. So those are the same equation. So with inverse variation, when you multiply the two variables, you always get the same constant number k. Okay? So you got to be able to recognize that. It's going to be very easy to mix these up if you start playing around with them. So just remember this. Y equals kx is direct variation. And you can rewrite that so when you divide the two variables, you always get the same constant. Those are both situations of direct variation. Again, if you have y equals a constant k divided by your variable x, and you rewrite that one by multiplying both sides by x, in other words, when you multiply your x and your y, and you always get the same constant number k, that's also going to be inverse variation. Do you understand? Okay, so you cannot mix these up. It's going to be very easy to do if you're not careful. All right, so here we go. All right, we're going to go to the example. So, Joey, can you read this, the directions here at the top, please?
For each table of values, determine if they represent direct variation, inverse variation, or neither. If they do represent inverse variation or direct variation, give the equation.
Okay, so, you guys, let me just say this, okay? Let me say something. On your homework tonight and on your test, which is, by the way, this Friday, listen closely, I'm not going to give you the rest of the table. I'm just going to give you the tables that look like that. And so to figure out what type of situation it is, what are you going to do? What are you going to do? Well, you're going to think about what we said a minute ago, which is when you divide y over x and you always get the same constant, that's going to be what? Direct variation. When you take your x's and multiply by your y's and you always get the same constant k, that's going to be what? Inverse variation. So which is why in your table, I suggest you do y divided by x and see if you see a constant, and then you take x times your y and see if you see a constant. Does that make sense? So that's why you see what I did in the rest of the table. Okay, I'm going to take your y's divided by your x's, and then you might also need to take your x's times your y. So here we go. So if I give you this table of values here, what are you going to do? Well, you're going to take y divided by 0.5. What's 12 divided by 0.5, guys? You should be able to do that in your head. What's 12 divided by 0.5? What is it? No. 24. Aren't there, in other words, what's 12 divided by a half? How many halves are there in 12? 24. Okay? And then what's 6 divided by 1, guys? 6. What's 3 divided by 2? 1.5. And what's 1 divided by 6? Point what? Yeah, 0.16, isn't it? I mean, you can use a calculator on these. 0.16, isn't it? Or 0.17 or so? All right. So when you take your y values divided by your x values, do you always get the same constant k? No. All right, how about here? What's 12 times 0.5, guys? What is that? 6. What's 1 times 6? 6. What's 2 times 3? 6 times 1? 6. So when you take x times y, you get a constant k. So think about it. Is this direct variation, inverse variation, or neither? When you multiply the variables and get the same constant k, what is that? Direct variation, inverse variation, or is it neither? Which one is it, guys? It's like your taffy problem, right? It's what? Inverse, isn't it? Okay? And so your equation clearly is what then? Well, when you took your x times your y, you always got what? 6. So that's the easiest way to write your equation. Do you agree with that? Yes or no? Now, I'd like you to solve this for y. So what do I get, or how do I solve for y here, Jake? How do you solve that for y? What do you do to both sides? Times it by x will turn that into x squared. That won't solve it, will it? So what did you mean? How do you solve that for y? Instead of multiplying by x, you what? Divide by x. And so you get y equals what? 6 over x. Okay, so I kind of did that here. Okay? Any questions, guys? Do you agree that's correct? Yes? Okay. All right. Everybody do the part B on your own. Give it a shot. Everybody try B. By the way, the situation can't be both direct and inverse, can it? No. So as soon as you discover which one it is, you don't have to check everything. Okay? Got it? You can try C while you're at it. You might as well. Yeah, but I'd rather you get decimals on this so you can see whether there's a constant there or not. Okay, so I'd rather you get decimals. Okay, here we go. Michael C., can you just read these straight across here? What do you get when you divide y over x? What do you get here?
4.
How about here?
4.
Here?
4.
Here? 4. Okay, and here, what do I get, Joey?
4, 36, 64, and 100.
Okay. All right, so in this case, and again, you guys, I'm telling you right now, on the homework tonight, I'm just going to give you that. Okay, and so you're going to have to do the y's divided by your x's to look for a constant, and then you're going to have to do the x times the y's perhaps to look for a constant. Is that clear? Yes? And so what happens here, guys? Is this inverse or direct variation or neither? What do you think, Katie? It is direct. I agree. And the reason is because when you took your y divided by your x's, you always got the same constant 4, right? Okay, so that's an example of direct variation. And so what's the equation here, Zach?
Y equals 4 times x.
Okay, but before you get to that, you just notice that when you take your y's divided by your x's, you always get 4. So everybody agree that that's the equation? Yes? And then Zach, from there, I wanted you to solve for y. And so how do you solve that equation for y? What do you do?
You multiply x.
Yeah, you multiply by x on each side, yes? And that gives you what? Y equals what, Zach?
4
4
times.
times x, good. Okay? All right, so you should be able to recognize these two as being direct variation. You should be able to recognize these two as being inverse variation. Is that clear, guys? Okay, now let's do the next one. Claire, what do you get here when you take y divided by x? And you can use decimals, I don't care.
4, 3.
Keep going. You can use decimals.
5,
Wait, 10 divided by 4 is what? You can give me a decimal on your calculator. 10 divided by 4 is what? And what's this one here? 2 point, you said what? 2.4? Okay, and then what about x times y here, Matthew? What do you get here?
4, 12, 40, and 60.
Okay, so what do you think, Maddie Green? Is this direct variation, inverse variation, or neither? Neither. Okay, everybody agree? When you divide your y's by your x's, you don't get a constant k, and when you multiply them, you don't get a constant k. So this is neither. Do you agree? It's right? Do you agree? No, you don't have to find the equation if it's neither. Okay, so any questions there? Okay. Okay. All right, so now what's different on example 2 is I'm telling you the type of relationship. So in this case, I'm telling you it's what? That y varies directly with x. And so as soon as I tell you that, I want everybody to write down y equals kx. I mean, you could write it the other way if you wanted. You could write it y over x equals k, but it's easy to remember it this way because you can just say, okay, if y varies directly with x, that means y has to equal some constant k times the x, right? To make it linear. That's the easiest way to remember it, right? That direct variation is linear. And this is like y equals mx, right? Just like y equals mx plus b, where b is 0. Do you understand how it's easy to remember this way? Yes? Okay, and so, well, if you know it has to be that, then all you got to do is you need to find what? You need to find what? K. If you find K, you'll be all set, right? And so any suggestions on how I might go about finding K? Any suggestions? Go ahead.
For x, put in -2.
Okay, hold on. Wait. So you're going to write y equals kx, and in place of x, you said put in -2. Okay. Yeah. And at the same time, you can put in 8 for y. Very good. Thank you, Ben. And now I think we can all solve for k, can't we, by dividing both sides by -2? Do you agree with that? And you get what? K equals what, guys? -4. So as soon as you find k, I want you to update this equation. Okay, so as soon as you find your k, just update that equation by writing y equals -4 times your x. Okay? All right, so clearly, to graph that, you can use a number of methods. You could just plot points by picking different x values, kind of like you did in the activity, right? You can do it that way. Just pick x values, plug them in to get y values, and plot points and connect them. That's one method. Or you can recognize it as what? A line with a slope of -4 and a b of 0, right? Do you agree? Okay, but it's up to you. Okay, it's up to you how you want to graph that. Okay, you can just plot points, or you can use M and B. Well, you know B is 0, so you know it's going to pass through 0, 0, and then what? You can go what? What's the slope? What's the slope, guys? What's the slope of the line? Oh, I can't hear you guys. -4. So you can write that as -4 over 1, right? So you know what? Goes through 0, 0, and from there you can go down 4, right 1, down 4, right 1, and so on. Careful here. Okay, so there it is. And again, another way you could have done it, just pick points. When I plug in 0, what do I get for y? Quick, guys. 0, so you could apply to the point 0, 0. What do I get when I plug in a 1? I get the point 1 comma what? Come on. 1 comma -4. When I plug in a 2, I get the point what? 2 comma -8. So you could have done it that way as well. Do you agree? So one way or another, you should all be able to graph that situation if you had to on your own, right? Okay. All right, everybody try B. Give it a shot. Already done? Done? Keep going. Okay, here we go. Taylor. Okay, so right up front I'm telling you that y varies directly with x. So in other words, y equals some constant k divided by x is the best way to remember that, right? So clearly we need to find k. So what did you do to find k?
I put 5 in for y,
Okay.
and then I did k over 2.
Yep, and you put 2 in for x, okay? And then to solve for k, what do we do to both sides there?
You multiply them both by 2.
Okay, so if you multiply both sides by 2, I get 10 equals k, don't I? And so I want you to update this equation now and write y equals your 10 divided by your x. Okay, so again, does everybody agree that's your correct inverse variation equation here? Okay, and so we know that the graph is a hyperbola. Again, the word hyperbola is new to you, right? Hyperbolas are the set of those curves that you get when you graph this type of equation, where you have a variable equals some constant number divided by the other variable. That's when you get a hyperbola, right? Is that clear? And again, the best way to graph the hyperbola is just to plot some positive and negative, or to plot some points that have positive and negative x values. So, now remember, you're going to be putting them into here and taking 10 divided by those numbers. So I don't want you to randomly pick some numbers here. I want you to pick some numbers that would divide nicely into 10. And so give me one here, guys. What's one? Negative 10. Okay, what's another one? Negative 5. What's another one? Negative 2. And then I can just use those positive values as well. Again, there are some other ones you could have used, but those are definitely some nice small numbers that divide nicely into 10. Everybody agree? Okay. And again, you could technically pick anything you want, but by picking these numbers, it makes the math easier, doesn't it? Yes? Okay, so when I put a negative 10 there, what do I get? Quick, everybody. Y equals what? Negative 1. What do I get here? John, go ahead and just read here. When I put a negative 5 there, what do I get? Go ahead, John.
Negative 2.
Okay, how about here? Go ahead. Negative 5. How about here?
0.
Well, be careful. 10 divided by 0 is what? It's undefined, isn't it? Yes? Okay, and then how about here? What do I get, Lexi? How about here?
2.
And here?
1.
1. Okay. All right, so you guys, I think we have enough points to get a pretty good idea of what my hyperbola looks like. So let's just go ahead and plot these points. Negative 10, negative 1 is here. Negative 5, 1, 2, 3. Negative 2 is here. And negative 2, negative 5 is here. Okay. And so if you connect them, it's going to look like this, okay? And then when you plot the other points, like 2, 5, and so on, let's see what we get. Okay, so you get that familiar set of curves, which is called a hyperbola. Do you agree? By the way, you should all be able to look at that graph and tell me what the domain is. Remember, the domain is all possible what? X values. So, if this keeps going this way forever, this keeps going this way forever, but it never, the X is never what, guys? The X is never what? Yeah, so X can never be what? 0. Do you see anything else that X cannot be? Is there anything else that X cannot be? Nope. So you can just say all reals X except what? Except what? 0. So that's how you write except 0. Put an equal sign with a slash through it. So any real number except 0. Do you agree? Yes? Okay, what about the range? What y values are you going to see on that graph? What do you think? Okay, go ahead. All reals y what? Except 0. Everybody agree that same with the y values. This is going to go up and up forever. This is going to go down and down forever. So y can be anything except here, which is what? 0. Do you understand that, guys? Okay, next page. 2 more pages and we'll be done. All right, the good news is I'm not going to make you graph on this one. All I want to do is write the equation. So, Chelsea, can you read it?
The variable varies directly with x when x equals 3/5 and y equals 6. Write a direct variation equation y equals 8x that relates x.
Okay, so what would you do here? Okay, now look, again, on the homework and on the test, it's only going to look like that. I'm not going to tell you what it looks like. You're going to have to remember that. So as soon as you read that, everybody, what are you going to write down when you read that? Y equals what? K times X. Again, I'm not going to give you that on the homework or on the test. You're going to have to remember that. When it says Y varies directly with X, that means Y equals some constant K times X. Okay, is that clear? Okay, and so what are you going to do now, Chelsea? Obviously, we need to find K, so how are you going to do that?
I move like 6 in for Y, and then for that to K, and move the this front.
Okay, good. All right, now, let me ask you guys, what's going to be the easiest way to solve that for K? What are you going to do to both sides? Michael B., what are you going to do to both sides to solve that for K? Yeah, multiply both sides by 5/3, right? Yes? Okay, so clearly the 5s and the 3s would cancel, leaving you with just K. And over here, be careful. Can't you write 6 as 6 over 1? Can't you? Okay, and so when you multiply those, you get what? 30 over what? 3, which is what? 10. Okay, and as soon as you find K, I want you to update that. And you get what? Y equals what here? Michael C., what do you get? Y equals what? That's right. Okay, so everybody agree that that's my equation for this situation then, right? All right, so again, on tonight's homework, and as well on Friday's test, you're going to have something that looks like that. And I'm going to ask you to write the equation. So this time, y varies inversely with x. So as soon as you read that, what are you going to write, guys, when y varies inversely with x? You're going to write y equals k over x. Is that clear? And then obviously you're going to find k, right? All right, so Maddie V, what are we going to do to find k here? Be careful. Go ahead. Plug in what? Okay, so in place of y, I'm going to put in 3/4. And in place of x, I'm going to put in what? -8. And then clearly I'm going to need to solve for k. So how do I solve that for k? How do I get k by itself there? I do what to both sides? Okay, good. So everybody agree you'd multiply both sides by -8? Yes? So you get k equals what? By the way, can I reduce the 8 and the 4 before I multiply to make things easier? Yes? So let's see. 4 goes in there once and there twice. And so what do you get, guys? What do you get? Come on. -6. But agree you get -6 over 1, which is -6. Okay, and so as soon as you find k, I want you to update this equation with your k value. And what do you get? Y equals -6 over x. Okay, so all you got to do is put in your x and your y to find your k and then write your final equation. Everybody get it? Once again, you guys, as things get more and more difficult, it's more and more important for you guys to have your notes out when you're doing your homework. Okay? And when you're studying for a test. There's no way you're going to remember everything we did every day when you're weeks down the line and you're studying for a test. You're going to have to get things out. Same thing with your homework. I mean, we did a lot. If you need to peek at your notes, that's fine. Okay? But you need to be able to do things correctly on your homework. Okay? Good? All right. All right. I'd like everybody to try example 4A and B. Give it a shot. You can use a calculator on these for the calculations if you want. Just like your cooperation grade. Again, I mean, if you read a word problem like this and you're not sure what type of relationship it is, just, you know, make a little table, right? Pick some x's, see what the y values are, and see if you can figure it out. And then once you decide what type of relationship it is, I might also ask you to write an equation. I don't think I asked you for an equation here, did I? No, I did not ask you for an equation. But you could come up with one, I think, if you really needed to, right? All right, so here we go. Harry, real quick. If you got one person, how much is it per person? Now, one person. 12. How about two people? The pizza's $12. If two people are paying for it, they each pay how much? How about here? How about here? How much? 3. Okay. So what do you think? Inverse or variation or direct variation? What do you think, Harry? Okay. It is inverse. And if you're not sure, how can you figure it out? Well, clearly when this goes up, these are going down. That's one way. Another way is to figure out what? That your x times your y is always equal to what? Is always equal to what? Is always equal to what? 12. Isn't it? Isn't your x times your y always equal to 12 in this case, which you should recognize as inverse variation? And if you don't recognize it in that form, if you divide both sides by y, you get y equals 12 over x. And so maybe you recognize it in that form. Does that make sense? Yes or no? So either way, one way or another, you better recognize it as inverse. Do you agree? I mean, there it is. Okay, so what are you going to put here in the table, Katie? That's right. Number of cans. And what are you going to put here, Katie? Yeah. The amount of money you get, right? Dollars. Or you can use cents. That's fine, as long as you tell me what it is. Right? Okay, so that would be your x and that would be your y, wouldn't it? Okay, so for one can, you're going to get what? $0.1. 2 cans, you're going to get 0.2, and so on. Do you agree? Whoa. I meant to do this. Sorry about that. All right, so clearly, as x goes up, the y values are going up directly, aren't they? So this is definitely what? Direct variation? Okay. And by the way, what do you notice each time you take your y divided by your x? Each time you get what? What do you get each time, guys? What do you get each time? You take your y's divided by your x's. What do you get each time? 0.1. All right, or 0.10. And so clearly when you have y over x equals a constant, that's direct. If you want to recognize it in a different form, all you got to do is multiply both sides by x, and you get y equals 0.10 times x, which again is definitely direct variation. Do you agree, guys? Yes? All right, last page. Hang in there, guys. Okay. So is this first one inverse or direct? What do you think, Sarah? Okay, it tells you inverse. Okay, so what you want to do is just write it in order. Start with the variable p equals, right, okay, for inverse, isn't it a constant k? Divided by the winnings. No, I'm sorry, the number of winning tickets, right, W? Okay, and so just all you got to do is read it and write the equation. Okay, so inverse would be the P equals your constant K divided by your other variable W, which is number of winning tickets. Think about that. The more winners, the less money each winner gets, right? So as one's going up, the other one's going down. That's inverse, right? Yes? Okay. Okay, and suppose the amount you save varies directly with the number of months. Who's got that one for me? Raise your hand. Go ahead. Okay. Okay, directly. Remember, inverse is where it's k divided by the other variable. So this time it's a equals k what? This is direct. Maybe you missed that. It's k not divided by oh, I'm sorry. I thought you said times. Yes, okay. I thought you said divided. Sorry. You said times, right? You say multiply or times? What did you say? Okay, times. That's fine. Okay, that's good. Everybody agree it's, like she said, a equals k times n? Yes? That's right. Okay. All right. All right, good. Now, last one. We're going to take it a step further, okay? All right, so Jordan, can you read this for me here? Real loud?
Yeah. The length L that a spring will stretch varies directly with the weight W attached to the spring. If a spring stretches 1.4 inches when a 20-pound weight is attached, how far will it stretch when an 11-pound weight is attached?
Okay, so think about that. Well, I don't think we're going to be able to answer the question without an equation. Okay, so I'm not going to be able to use that 11 until after I find an equation. Okay, so the first thing we want to do here is write the direct variation equation, and then we'll be able to use it to answer the question later on. Does that make sense? Okay, and do you agree with that? The more weight you put on, the more the spring is going to stretch, right? I mean, if you got the spring and you put a weight on the bottom, the more weight you put, the further the spring is going to stretch. Do you agree that's direct variation? Right? When the weight goes up, the amount that it's stretched goes up. Do you agree with that? Yes? So that's direct variation. Okay. So, I want you to use L, I want you to use W, and I want you to use K. Somebody write the equation for me. Use L. I don't want a number, just I want to use, right now, start with L, K, and W. What's the equation here? Write it. Yeah, go ahead. Very good. See what he did? He just wrote L equals the constant K, whatever it is, times my weight, because it's direct variation. Just like Y equals K times X. Do you agree? Okay, now clearly we need to find K. And so how am I going to find K? Who's got an idea on how to find K here? Hold on, Mark. Let me have someone else give it a shot. Who else can help me here? Go ahead, Conrad.
You have to put in 1.420.
Okay, where does 1.4 go? For what? L or W? L, okay. And where's the 20 going to go in place of what?
W.
Okay, good. And now you can get your calculators out and divide by 20 to get your K, right? What is it? What's 1.4 divided by 20? Somebody with a calculator, what is it? 0.07 or 0.7? 0.07. 1.4 divided by 20. Is that right? Okay. All right, now what? Now what? Now that I have my K, I have to what? Update this. Okay, so I'm going to update it to write my L equals 0.07 times my W. Okay, but now I have not answered the question yet. What was the question I was trying to answer, Jake? I was trying to find what?
How far it'll stretch if it's left out.
Okay, so now you want to find L when what? W you said equals what? 11. But you agree that we need to find L now when W equals 11? And what is it? Somebody with a calculator, what is it? 0.77 what? Inches, pounds, days, years, weeks. What is this? Inches? Okay. There you go. Okay, so if a 20-pound weight stretches at 1.4 inches, an 11-pound weight will only stretch at 0.77 inches, according to our math. Got it? All right, everybody try B. Make sure you answer the question, right? Not only do you need to write the equation, clearly then you need to use that equation to answer the question. Okay, you guys, you see how, someone that would sell mulch would need to do this math, wouldn't they? I mean, if a customer calls and says, I've got, I want to cover my garden or around, the front or side of my house, and I want I want like a ½ inch of mulch or 2 inches of mulch. You see how the company would need to do this type of math to figure out how much mulch they need, right? Make sense? Okay, ready, guys? Okay, so here's the key word right there. Varies inversely. Okay, so you're going to start off by writing what here, Shelby? A equals what? What's that? A equals K over X? Okay. But instead of X, it's what? K over D. Okay. Everybody agree that's what you need to start out with when it says inverse variation? Okay, so now clearly I need to find K. And so how do I find K here, Claire?
You can put in base 24 for A, and then you put in 6 for D.
Okay. And so to solve for K there, you guys, don't I need to multiply both sides by 6? Everybody agree? Okay. And go ahead and get your calculators out. And what do you get? What do you get? 1944. Okay. And so once you find your K, you're going to have to update your inverse variation equation. And you get y equals 1944 over d. And now that you have your equation, you should be able to use it to answer your question. Okay? And so, Jake, what am I going to do here to answer my question?
Oh, you're going to update it.
I did update it. Okay, now what? Now I want to answer the question. How am I going to figure out the depth that will be covered by 587 square feet?
You plug in 587 for Y.
For y, yeah. By the way, instead of y, it's a. I messed up, right? This should be a instead of y. Sorry about that. But you agree that should be a instead of y? Okay, go ahead. All right, so go ahead. You said put in 587 in place of what? A. All right, now be careful here. This is where it gets tricky. This is the tricky step right here. How in the world do I solve for D here? Well, I don't want to multiply by 1944 because that'll just make that number bigger. That won't get rid of it. If I divide by 1944, yeah, that'll get rid of that, but D will still be where? D will still be in the denominator. I don't want the D in the denominator. So the key here is to get your D out of the denominator. How do you get the D out of the denominator? Yeah, very good. Okay, hold on, Ben. So he says multiply both sides by D. Very good. Once you do that, I think the rest of it will be very easy. So you can't solve for D if it's in the denominator. So you're right. The first thing you want to do is multiply both sides by D to get it out of the denominator. And now I think it'll be very clear on how you finish solving for D. So what do I do now, guys? What do you do? Yeah, divide by 587. So again, I want to emphasize that. You cannot easily solve for a variable when it's in the denominator, so get it out of the denominator. And then from there, it'll be more obvious on what to do next. Okay, so what do you get? D equals what? Get your calculators out. What's 1944 divided by 587? What is it? 3.31. About? And what is this? Inches, feet, square feet, miles, yards, inches. Not square inches. This is D. This is the depth of the mulch, which is what? Just what? Inches. The area is square inches. Is that clear? So this is just inches. So that's how deep you'll be able to pile the mulch. You'll be able to pile the mulch 3.31 inches deep. Is that clear? Okay? All right, so look. So you got a bunch of book problems, and I've got one other problem for you to work on. Where is it? Oh, hold on. Let me find my book here.